This is Norm Christofferson, Senior Trainer with Johnson Controls. In this video I'm going to answer the question, what is standard air? ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, created a reference point for air called standard air. This is not something we're trying to achieve, but rather this is a point we can refer to while talking about air. I will be using this standard air a number of times in future videos as we continue in this series. Let's take a look at the list. Standard air is air that is at sea level. It exerts a pressure of 14.7 pounds per square inch absolute. It's at 70 degrees Fahrenheit and it's 0% relative humidity. It has a specific heat of 0.24 BTUs per pound per degree Fahrenheit, and it has a density of 0.075 pounds per cubic foot, and finally a specific volume of 13.33 cubic feet per pound. Let's take a little closer look at each one of these. If you were standing at the edge of the ocean, there would be about 60 miles of air above your head. That air has weight, and that weight puts pressure on your body. Each square inch of your body would have a pressure of about 14.7 pounds of pressure pushing on it due to the weight of that air above your head. So we say that at sea level air pressure is 14.7 pounds per square inch, atmospheric or absolute. Temperature is a measurement of the speed of the vibration of atoms and molecules. Temperature is a rate of vibration. The higher the temperature, the higher the speed of the vibrating atoms and molecules. Temperature is not a measure of heat quantity. It's a measure of heat intensity. ASHRAE picked 70 degrees Fahrenheit for the temperature of standard air. Relative humidity is a measurement of the amount of moisture air contains. ASHRAE decided to use dry air, that is air at 0% relative humidity, for standard air. This will make more sense later on. The specific heat of a substance is the amount of heat it takes to change the temperature of 1 pound of that substance by 1 degree Fahrenheit. The specific heat of water is 1. That's also the definition of a BTU. It takes 1 BTU to change the temperature of 1 pound of water by 1 degree Fahrenheit. The specific heat of air is different. The specific heat of air is 0.24 or almost 1/4 of a BTU. If you were to add 1/4 of a BTU to 1 pound of air, it would raise the temperature of that air by 1 degree. Adding an entire BTU to 1 pound of air would raise the temperature of the air 4 degrees. Air is 4 times easier to heat or cool than water. The specific heat of standard air is 0.24. When we talk about air density, we're talking about the weight of air. Density is the weight of a cubic foot of air. If you could capture 1 cubic foot of air and weigh it, it would weigh 0.075 pounds. That doesn't seem like very much, but it's going to add up quite quickly. For example, a room 10 feet high, 10 feet long, and 10 feet wide contains 1,000 cubic feet of air. Each of those cubic feet weighs, assuming standard air conditions, 0.075 pounds. So 1,000 cubic feet times 0.075 pounds per cubic foot equals 75 pounds of air in that room. One more short example. A blower in a small residential heating system is moving 2,000 cubic feet per minute. That's 150 pounds of air per minute. That is work requiring horsepower connected to that blower shaft inside that furnace. The specific volume of air is the reciprocal of the density of air. The specific volume is the volume of air in cubic feet required to collect 1 pound of air. In order to collect 1 pound of air, assuming standard air, you would need a cubic foot box 13.33 cubic feet in size. Therefore, a room containing 1,000 cubic feet of air is holding 75 pounds of air. Just divide the 1,000 cubic foot room by 13.33 cubic feet per pound to get the weight. Specific volume and specific density are the reciprocal of one another. If you know one of these numbers, simply divide it into 1 and you'll get the other. So there you have it, ASHRAE's standard air. Standard air will be highly useful in future videos in this series. Standard air is also useful when looking at equipment ratings. and using the psychometric chart. This is Norm Christofferson. Thanks for watching.